hear me, I am going to do 2 to 3 problems apiece from the extra practice I sent out yesterday and the previous session prior to that. It's about chain rule and implicit differentiation. I'll probably do about 2 apiece, just so in that way the file isn't too big and I can actually send it to you via email. If you guys have any questions, please email me and I will get back to you with a video response or the answer key answer. So let's get started. Okay, starting with the chain rule problems. I'm going to do number 1 just because it's probably the simplest and it's a building block for the later problems. So let's get started. So I have y equals cosine 4x. So in this scenario, cosine is the outside function and 4x is the inside function. Why am I making that distinction? Because this is not the parent function of cosine x. There's a difference. Y equals cosine x. You would just derive it normally, it would be negative sine x. But because there is something here, you have to apply chain. So let's quickly get started. So based on that, I'm going to start with the derivative of the outside, which is cosine. The derivative of cosine for x. So right now I'm just focused on cosine. So therefore, I'm just going to derive the cosine part. The derivative of cosine is negative sine. And I'm just going to carry this down with me. So there we have it. I derived the outside. But I'm not done yet. I also have to multiply it by the derivative of the inside. So the derivative of the inside is 4x. So the derivative of 4x is simply 4. So your final answer here is going to be negative 4 sine 4x. If I wanted to do du dx, I would say u is 4x. So then therefore it'd be cosine u. So then I would say d over dx cosine u, which would give me negative sine u, which then I could write as negative sine 4x again. And then I still have to derive u. So the derivative of u which again gets me the same 4 sine 4x. I promise that's a 4. My pen just doesn't like me. So does that make sense to everybody? That's how I would do it. I most of the time stick to just this side because I determine the inside and the outside of the function, and then I just do it that way. I know some of you guys are super comfortable with this du dx. Me personally, I forgot it and now I can't remember it for some reason. So that's why I do this work the most of the time. Okay, let's go to the next one. So this one is tan squared 2x plus 1. This one looks a little bit ugly, so I'm going to rewrite it. I'm saying the exact same thing. This is totally fine to do if it is easier for you to see the chain. Now, there are 2 chambers in this. Why do I say that? Because in the last one, we said this was the outside and this was the inside. However, now you have this squared. So you have to do two separate chain rules. So first I'm going to do the derivative of this squared. So all I'm going to do is say I am not worried at all about the inside. The only thing I'm worried about right now is the power rule on the outside, if that makes sense. So all I'm going to do is bring my 2 down and then tangent 2x plus 1. And that's it. I did that outside power rule. I'm done. Okay? But now I have to worry about the first inside. So now I'm looking at this tangent. Okay? So times so again, I'm not worried about this piece right now. I'm simply looking at tangent. So what's the derivative of tangent? Secant squared x is the parent function. But because I have something in here, it's just going to be this written again. So it'll be secant squared 2x plus 1. That's it. All I'm focused on is tangent. So I just derived tangent and I know what it is. It's secant squared. And then I just bring whatever's in the parentheses down with me. Okay. So last but certainly not least, I have to derive the inner side most function. So here we go again. So 2x plus 1, I already just know it's 2. Very simple power rule. And now I'm going to put it all together. Honestly, I would just leave it as 4 tangent 2x plus 1 secant squared 2x plus 1. All I did was combine this and this to get the derivative. Okay. In this, it's just a matter of seeing the outermost outside, another inside, and another inside. Now, it's very complicated. This is where the du dx starts to get confusing. If I wanted to do it, I'd say dx, and then I would say u squared, u being tangent 2x plus 1, which would then give me 2u, which would give you this one back again. So 2 tangent 2x plus 1. Terrible handwriting, I know. Also, if you hear background noise, I also apologize for that. So finish that one. Now I'm done with u. But now I have to worry about tangent and 2x plus 1. So I could say, I'll make it v for funsies. So now I'm looking at, so it should be u, it should be v. Tangent v. So now I'm just focused on tangent. So then therefore I just know it's secant squared v, and I know v is that 2x plus 1, so that would give me secant squared 2x plus 1. And then again, I would have to derive this. I'd give it another thing like w and say 2x plus 1, sorry, 2w plus 1. And then I would say, oh, it's just 2. And then I'm done. DUs and DXs and DVs and all of those are applicable. You can use them. It just gets a little bit confusing because you constantly have to keep changing. Hence why I just identify and then move inside as I go. and then just make sure I know what I'm focusing on. I'm going to do one more chain rule, and then I will go on to implicit. The rain is terrible. I so apologize. Okay, so here we are again. Sine 3x squared to the 5th power. I'm going to leave it as is because it's really pretty decently easy to identify what's what. So already I'm going to say my outermost is everything to the 5th power, okay? That's simple power rule. I'm not going to stress about it. The next most inside thing is my sine, okay? And then my innermost parentheses, my most inside is at 3x squared, okay? So working from the outside in, okay? D dx sine 3x squared to the 5th. I'm simply focused on this power. I'm not worried about anything else. It's just going to follow me down. Okay, so that's 5 sine 3x squared to the 4th. And now I'm done. I'm not going to touch it anymore. I'm not worried about the 5 to the 4th, anything. That's it. Okay, now moving on again to sine 3x squared. I forgot to d to the dx. Okay, again, I'm not worried about this innermost bit right now. I'm simply focused on sine. And I know the derivative of sine. That's not hard. It's just cosine. So cosine 3x to the 2nd. Again, I'm just arrived in the outside. I'm not worried about this inside just yet. Okay, so that's it. I'm done. I'm going to leave it alone. Okay, now times the innermost inside. Squared. So I have worked my way in from the exponent to the trig function to the innermost parentheses. Again, we all know what a power rule is. This is just 6x, okay? And now we're all done. I'm just going to combine things just to make it look nice. I'm not going to do anything crazy, okay? So 6 times 6x times 5 would be 30x, and sine 3x to the 2nd times cosine 3x to the 2nd. And that's it. Make that a double. I'm not going to do anything else. There's no true simplification I can do to make this any better. So that's chain rule. The other two, I'll post just a quick little work, like the answer key. But here are the video for chain rule. I'm going to make a second one for implicit. Thank you guys for watching. I really, really appreciate it. If you have any questions, please reach out to me. This time it's going to be implicit differentiation. I'm probably going to do about 2 examples, maybe 3 if we have time. I don't want to run this super, super long because then it's really, really hard to share the video. But let's go ahead and get started. Okay, let's do this first one. So we're going to start by just writing out d over dx x squared y plus y cubed minus 4x equals d over dx. Parentheses. I start out by just individually writing out dy dx for every piece. So x squared y plus d over dx y cubed minus not dy dx, d over dx 4x, it's a 4 I promise, and d dx 10. Okay, so I'm going to start over here. Now, as you can see, this is a product rule. Why do I say that? Because x squared is one entity. I'm going to call it f of x and then let's use range. G of x is y. Okay, that's why I'm saying that. They're sitting right next to each other, so it's an implied multiplication. So that's where we're going to start. So I'm going to start out with product rule. I'm going to do that in purple. So over here, okay, so f of x and then g of x. So f of x times y plus x times d dx y. Okay, so I just set up product rules. I didn't do anything. I just sat there and said, okay, what's product rule? Here it is. So the derivative of x with respect to x, that's just going to be 1. So it's going to be 1 times y plus, okay, so plus x. Now, the derivative of y with respect to x. So this is where we are implicitly differentiating. Okay, so because there's a y here, you're still going to derive. So the derivative of y is 1 times 1, but now you're going to have dy dx because now you're deriving y with respect to x. Okay, so I want to simplify that a little bit. It's just going to be y plus x dy dx. Okay, now I've done that. I'm not worried about it anymore. So I'm just going to write that here. Okay, now let's move on to the next thing. So here we are. It's just y cubed. It's going to be implicit differentiation, but because there's nothing next to it, it's just y cubed. It's just power rule. And we're going to do that really quick. So the power rule, bring 3 down, 3 minus 1, it'd be 3, oh my goodness, 3y squared times dy dx. Okay? Nothing too crazy. Now, this one, just normal differentiation, it's just going to be -4. And then this one, constant rule, just going to be 0. So if I put it all together here, it's be y plus x dy dx plus 3y squared dy dx minus 4 equals 0. Okay, so now I want to isolate. So I want everything that's attached to dy dx on one side and everything that's not on the other side. So I'm just going to do opposite operations. So minus y on both sides, minus y, and then plus 4 on both sides. Now I have x dy dx plus 3y squared dy dx equals -y plus 4. Okay, so I'm just going to write a little arrow over here. So what I want to do is factor out dy dx and then move everything that's not dy dx over to one side. So here's how I do that. Dy where dx is going to be x plus 3y squared equals -y plus 4. So all I did was factor out dy dx. I'm left with this. So now I want it by itself. So I'm going to divide by x plus 3y squared on both sides. Okay. So therefore, dy dx is -y plus 4 all over x plus 3y squared. And that'll be your answer. And that's it. So I'm going to go ahead and go to the next one because it's a little bit more complicated and we'll go over it really quick. Okay. So Sorry about that. Okay, so again, I'm gonna start it the exact same way. Dx squared plus y cubed is 6xy equals dx 0. So that will be separated in the last one. So x squared equals d dx y cubed minus d dx 6xy equals d dx 0. Okay, so I'm just going to go from left to right and start deriving. So already, this is just general power rule. It's x with respect to x, so I don't have to do any implicit anything. So it's just going to be 2x plus. Okay, so now here we are again. We are back with implicit differentiation. So we're still going to do power rule. So that's going to be 3y squared times dy dx to show that it is an implicit differentiating. Okay, and now here we are again. Another instance of y, so there's going to be some implicit differentiation. However, again, you have x's and y's in the same expression. So it's 6xy. So again, it's going to be product rule. I'm just going to go over here and do that really quick. Okay. Now, there's two ways you can do this. You can either do it 6x is one entity and y is one entity, or you can split up and remove 6 from x and y and just do x and y as one entity. I'm going to do both ways. I'm going to show you both. So f of x, there's going to be 6x. G of x is going to be y. Okay, first way. So d dx 6x times y plus 6x x y. Okay, so derivative of 6x is just going to be 6 times y. There's no implicit differentiating there because it's not. I'm not doing anything with the product rule on this side. So now I go 6x. Now derivative of y, that's going to be implicit. So times 1, that's the derivative of y, and then dy dx. So I'm going to rewrite that really quick. 6y plus 6x dy dx. Okay? Now, how I do it sometimes is I pull the 6 out. So instead, I do it 6 and then same idea. 6 is just sitting out here. Be 1 times y plus x times 1 dy dx, which would then just give me 6y plus x. And then I would just have to redistribute the 6. So it'd be 6y plus 6x dx. Both work. Both are totally okay to do. I just like working better with x and y. Just I think it's a little bit easier. But to be fair, sometimes I do forget. So let's not. If it doesn't work for you, don't do it. It's totally cool. 6y plus 6x dy dx. Okay, equals. And then the derivative of constant's always 0 no matter what, so don't even worry about it. So I'm just going to rewrite this really quick so we can see it better. Really quick, distribute your negative just in that way. You don't make any silly math mistakes because we all make them, and let's not keep in bad habits. Okay, so now we are at the final step of just moving everything from one side and having dy dx on the other. So I'm really quickly just going to do the algebra of that. Plus 2x plus 6y. Oh my goodness. My pen is out of control. Oh no. Okay, let's try this again. We are having technical difficulties. Okay, for some reason. That's horrific. Oh my goodness. That's 6y, I promise. Okay, so opposite operation on both sides. So plus 3y dy dx minus 6x dy dx equals 2x plus 6y. Factor out dy dx. You're left with 3y minus 6x equals 2x plus 6y. Okay. Again, just like last time, you're going to divide on both sides by this expression, 3y 6x. And so your answer is going to be 2x plus 6y over 3y minus 6y. And that's it. And there we go. So I think we have time for just one more really quick. Let's go to the next one. Oh my goodness. Okay. Let's see if I can erase that. If I cannot, then we're just gonna have to stop here. Oh no. Okay. So that is the end of this video. I will send out a completed answer key so you guys can check your work. And if you have any questions, please email me. Thank you. Have a good day.